Hello everyone, welcome to the Learner's House. In this video, we will start the point estimation topic in R. And before starting, we will have the 3 videos on this chapter. The first one would deal with how to fit a distribution, and then we will study the parametric and non-parametric bootstrap methods. So in this video, we will see how to fit a distribution on a data. Alright, so before starting, we have one thing to discuss, that how to import a data into R. So we will import the data into R by setting a working directory, and we can do this by clicking on session and then set working directory and then choose directory. Now the directory in which my file is saved is in folder which is in downloads, and then it is in data files. So I have clicked this. Now here I have my working directory in local disk C, users, downloads and data files. If I want that what is my working directory, then I write this command and then click on run or control enter also. So this is my working directory, I can see here. The other way in which we can do the same thing is press Ctrl Shift and R H together, and then we can see that we can select the working directory. So this is in this PC, downloads and then data files. My folder is selected. Please make sure that you are selecting the folder and not the data file. Like I have a data file named as claims. So I won't select the claims file here. I would select a folder in which my file is contained. So now I will click on open. And now the main thing which we have to keep in mind is how to, I have selected a folder in which my file is located, but how to bring that file into R. So we would do this by command read.table. So we will write read.table. In brackets we will write the name of the file, and that would be AGGCLAIMS, aggregate claims this says. But we have to make sure that we are writing the letters exactly same as the file name. We can't use lowercase or uppercase or deferred case. Like we have to write exactly same. So I will save this into claims and then I will run the command. So this says no such file or directory. Yes, the issue which we have faced here is we haven't wrote the format here. The aggregate claims has a text format. This is the text document which we can see here. This is the text document. So we have to write .txt here. Now we can run it again and then it is sorted. So let's view the data to see if it has imported correctly or not. View claims is a command, but the view thing, the V should be capital here. Now we can run it. So this is the claims. But we have one thing to see here, my claim value is starting from 23 and it is ending up to 51, and there are total 30 values. But the point of concern is that it has taken claims as first value, but claims is the heading. So we haven't tell R yet that this is the this file contains heading. So we will write header equals to true, because by default the header thing is false. Now if we run it and then view it again, so we can see that this is the heading claims here, and then from 1 the value 23 is here. So this is the thing which we have to make sure that our file is imported correctly. After this we will make a histogram of the file. So this says the error, and this error says that X must be numeric. So what is the problem here? Let's see. This means that our file, the folders, like this column is not numeric. This is not taking the file as numeric. So we will see that what the structure of the file is by writing structure claims, and it says that the structure of the claim file is data frame. But so this is fine, we cannot make the histogram of the data frame. We have to convert it into a numeric form and then we can make a histogram. So how to convert it into numeric form? Let's see it. We will write claims dot data, claims dot numeric डाल दे लाइक यहाँ पर डाल देते हैं ताकि हमें पता रहे कि ये numeric वाला है. Now we will write here as dot numeric and then we will write claims. Means we are saying R to convert the claims file into numeric and then save it to claims.numeric. Now we will press Ctrl and enter and it again says an error. So what we have to do now is we have to make sure that which column particularly we want to convert into numeric, because it cannot convert the data frame directly into numeric form. So what we can do here is our claim files are located in column second. So we can tell R that import change the structure of those columns which we are saying. So how can we do that? We have to do indexing for that. And how to do indexing? Let me explain that little separately. If I write claims, then it will give me this data. If I write claims and then square brackets, and then if I write 2, 3, then what it would give me? It would give me the second row and the third column, which is not in my data. So I can change it by second column. So this says null because it is treating it a first column, like this is the first column and this is no column. Let's see. Now we can get the the number which is 24 here. So we can see that this is second row and first column because this is not a column R is treating. So this is a way how to do indexing. For indexing we use the square brackets. In R we use really rarely the square brackets. The square brackets whenever used says that we are imposing a condition. So the condition here is we want the second row and the first column element. So in indexing we always have conditions, so that's why we write the square brackets. And in other in other places also, if we are imposing any condition, then we have to write square brackets. So we will see those later, but let's do it now. Now I want the first column. So how I will write it? I will put square brackets like this and then I will put a comma and then write 1. Now what is the meaning of this? This says that give me, like if it is blank, if the rows column is blank, like if I am writing 2 here, then it says that second row. But if I am keeping it blank, then it means that all rows, and comma 1. This says that we want to have all rows and only first columns. So if I do it now, then I can get the first row like this. So now I have to put this, only this into the command. So we can have this data converted into numeric form. So we will again write claims.numeric as dot numeric bracket and then claims, and then we want all rows and then first column. Now it is converted into numeric form. So the only way, the only purpose we have done indexing here is to convert that particular column into numeric form. The indexing topic is really vast and you all will study this into subject CS2, but for this purpose I have just explained a bit which we can do here, like to change the structure. Now we can also check the structure of the file claims.numeric. Let's plot the histogram now, and we can also see that the structure says that the file, the numbers, these numbers, and the file is numeric format. So let's write histogram claims.numeric. Let's run it, and the histogram looks like this, which is not explaining things correctly. So we can also apply breaks to it. The numbers are starting from almost 10 to 70. So let's write it from 10 to 80 for safer side. It looks really weird. The graph is not explaining anything. Let's see what the problem is. So we have to write it like we have to write colon here and not the comma. Now we can run this command again to plot the histogram. Now it looks fine. So this is the histogram, and now the main question starts. We want to plot the empirical PDF using the data. So if we want, then we can also write like this is a frequency thing. So we can modify this command and write plot density and not plot, density equals to true. The density command says that we want to plot the PDF of this data and not the frequency. So let's run it, and now it looks like this, but this is really less visible. Let's write a color. Now this is okay, but we have a few lines like this. So what we can do now is these lines like have no meaning. So the data which we have imported here is what I have made by myself, like the data values are not any real values. So these are just random values and they may not fit the data correctly. This is just for explanation purpose. So we will make a empirical density graph differently, like not in the histogram itself. So we can use the plot command and then density. We can also remove this density equals to true here. Now this is fine. We can write plot density and then the file name, which is as claims.numeric. So it looks like this, and this is the PDF of the data which we have imported here. After this, we want to superimpose the PDF of different distributions. So we will import two distributions here. The first one is Poisson, because the data taken closely relates to this, and then we can also take exponential. So we will superimpose these two distributions, and then we will also plot the QQ plot and then determine and interpret the conclusions from the graph. So let's fit the Poisson distribution first. So how we can do that? First of all, we have to see the range in which our claims values lie. So the range is from 17 to 67. So S is the value which we will take in exponential distribution to show the X part. That would be the sequence starting from, let's say, 17 and ending to 67, and the gap would be 1. So let's see this. This is the data. S is the data, but it contains 51 values, and let's say that I only want the 29 values or less than that. So I can also write the gap of 2 also. So it would give me 26 values almost. Now what I have to do is I have to write lines, because I want to superimpose the graph in this plot. I don't want to make a different plot separately, because in that way I cannot interpret that how my distribution is fitting. So I would write lines here, and then the first command would be S, which are the values, and then we would write the probability distribution, which is DEXP, and we can first write DPOIS S comma. Now like first we are fitting the Poisson distribution, and then we will fit the exponential one. The parameter, let's say we have 0.0987, comma, color is red, let's say we want. The values are not fitting it, it is pretty different, because I have mistakenly wrote the lambda part of the exponential distribution in the Poisson distribution. Like we have taken it 0.09 something, but that is for exponential distribution and not for Poisson. That's why the graph looked so weird. So now we will write, let's say 32 here. I will explain the choice of 32. So it looks like this. We have to increase the y limits to show the complete graph here. Like this is cutting here because of the less limit of y. So now the choice of 32 is basically from this mean part. Lambda, which we are fitting from Poisson distribution, is the mean of the data values, or you can say that is the population mean, but the statistical interpretation says that it is the mean. So we have the data, and now we are determining the mean of the data, which is 37.068. So I have taken 32 to make it close to 37. We can also take it 37 or the exact lambda value also. The graph wouldn't change much. So let's draw it again with the exact value. Now we can fit exponential distribution also here. Let's say I am writing lines S, D, E, X, P and then S, 0.0987, color is now a bit different. Now this looks like this. If we see it closely, then we can see that data values have nothing in common with the distribution, because this is just, the data is just for explanation purpose, that this is not the real data, and this would not fit that good. Now we have fitted the Poisson and the exponential distribution here. We have one more thing to discuss, which is QQ plot. What QQ plot does is it plots the quantiles, the sample quantiles and the population quantiles. And I hope if you have watched my introduction videos and the previous videos of the R, then you would know the meaning of these. So what sample quantile is, I can explain it once again. So this says that, let's say that I have some x and I want to know that which x is this. This line says that I have some x value, the area above than x is less than 0.75. So if I have to calculate these things, then I calculate it by determining the quantiles. We also determine median from this, and now I have to plot the sample quantiles and the population quantiles, but I would not do that from scratch. So what I will do, I will write QQ plot, and then let's say I want to fit the exponential distribution first. So I will write REXP because it will give me the values from exponential distribution. Let's say I want 29 values and the parameter value is this. Now we can save it in the vector x. Now I want to write x here, the data values of the distribution. Now I will write the original observed data, which is saved in claims.numeric. And now what I will do, I will write x label. X label says that I am plotting population quantiles, and then y label, which says that I am plotting sample quantiles. Now what it means, how I have written it differently, like why can't we write population quantiles on y? Because we have written population quantiles on first. The first value which we have written would be on the x-axis, and that's why this is the population quantiles, because this x is coming from population. Now we can run this command, and it looks like this. These are the population quantiles and these are the sample quantiles. And now we can again plot a QQ plot of Poisson distribution, but let's see this further. We have one more thing to discuss, which is AB line. We will see that how good this fit is, and we will do that by the command AB line. So what AB line does? AB line has mainly 4 commands which we can see A, B, H and V. If I don't write anything, then it would take everything null. But the meaning of A is that I want a line which will have an intercept and a slope, like the line which we draw like this. So this line or this line always have intercept and a slope. So the A is saying intercept and B is saying slope. H says that if line goes like this, vertical line or horizontal line. So for horizontal line, what point you want to take, and for vertical line, what point you want to take. So these are the things. Let's say I am comparing it with AB line 1, 0, which says that I have an intercept and slope. So now let's run it with the red color. We can't see it here. Let's check the help box with the command AB line. So the AB line A, B, H and V. Now we can see that the line has plotted. 1, 0 we written before this because the error in that command was we were taking slope as 0. So that's why we were not able to see that. The line is here. We have to change this intercept and this thing. Let's take intercept 5 and the slope same, let's say 1 we want. Now if we run, this is coming here. There is nothing in common with this line and their data values because of the fact that I have explained already. So like mainly our AB line comes here in this data, above this data, from where we can see that how our data values are aligning with the AB line, and then we can interpret that how good a distribution is. So that's it. And the reason which we can see clearly, the line is really far away from the data and has no meaning. If the line comes like this, I'm drawing it this way. If the line comes like this, then we can see that how many data values are aligning with this AB line. And if there are really less data values aligning with this line, then it means that we have a poor fit in this way. So this is the way in which we fit any distribution on our data. This was just the way of explaining, like you can do this with any data you have. So you can also fit exponential distribution on this particular data, and then you can conclude that which one is really better. So this was it for the video, and in our next video we will come up with the parametric topic, like the parametric and non-parametric bootstrap. So see you in the next video. Thank you so much for watching.